Hello, my name is Austin Beecham, and I'm a solutions engineer at Bytecode. I'm excited to share how we built a machine learning model inside of Looker to help a local retailer deal with customer churn. Today, we're going to discuss designing the model, creating, training, and evaluating the model, and using the model to predict results. Let's get started. First, we need to design the model. We built a logistic regression model to predict whether a customer would or would not return to the store within 180 days of their first purchase. For features, we chose to include information about a customer's first purchase, including which store and department they purchased in, whether they're local to the store, how much they spent, how many items they bought, and their discount level. Now let's jump in and show you what we built. Let me first show you the view that we're generating to feed the BQML model. This is a per customer view that lays out all the features of a customer's first purchase. This also includes the label, repeat purchase within time. This is a yes/no field that indicates whether a customer is considered a returning customer. We define a returning customer as someone whose second purchase is within 180 days of their first purchase. The next step is to split historic customers into training and evaluation views. 80% of these customers will be included in the training view, while the other 20% of these customers will be included in the evaluation view. The approach of defining views within the semantic layer to feed the model is perfectly agile, making it easy to change and maintain. Any change to the semantic layer will cascade through this view and into the logistic regression model. For instance, if the definition of how we define a local customer changes, that will flow all the way through the model and affect the predictions. In addition, leveraging the existing dimensions in the semantic layer accelerates the process, and adding new dimensions accelerates future analysis and matures the semantic layer. Now that we have our training and evaluation views ready, we can now create the logistic regression model. This is the statement that creates and trains the model. The model will evaluate every customer's first transaction and identify correlations, which will be used to predict how likely a new customer is to return. In the model type, we specify that we want to use a logistic regression model. There are lots of other options for models, including custom models written by the data science team and loaded into Vertex. We'll cover these options in a future session. For labels, we list the field we want the model to predict. In our case, that's repeat purchase within time. Here we also enable global explain, which explains the correlations the model is using. We will review this a bit later. At the bottom of the statement, we are specifying the training view we have prepared. Lastly, we use a data group trigger to instruct Looker to retrain this model once a month. Once we have created and trained our model, this global explain statement generates the following helpful insights. Basically, this shows how correlated each of the features are to the predicted value. It is interesting that average discount is near the bottom of correlated features, since the president of the company of the shoe store believed that this was the primary reason why customers returned. This is where we run the evaluation using the evaluation view. Basically, the set of customers we have reserved to test the model. The evaluation results provide insights into how well the model is performing. Since this is a logistic regression model, it provides scores on accuracy, precision, recall, etc. It is interesting that the false negatives are high, which means the model is often incorrectly predicting that a customer will not return when they do return. We want to avoid false negatives in this scenario, as we don't want to build our marketing campaign list too narrowly. Let's step back and examine the power of leveraging data science models within SQL. Most importantly, this approach brings the model to the data rather than the traditional approach of bringing the data to the model. This speeds the process of executing models, especially on large data sets, and it is more secure and less costly. Building quality models is an iterative process. Therefore, the ability to make changes and retrain quickly lead to better predictions. Leveraging SQL enables data analysts and engineers to build and execute data science models that used to be reserved only for the data scientists. These models can be written, changed, and executed from Looker, further enabling the analyst community that may not have direct access to BigQuery. Now that we have built and evaluated our model, we are ready for the fun part, using the model to predict the future. This is a statement that produces the predicted values. We simply feed it the prediction view and the model, and it produces a list of customers with all of their features and includes the prediction and the confidence interval. We can use the confidence interval with the prediction to more precisely use these predictions. For example, we can create a list of all customers who are predicted to return with a confidence interval of greater than 60%. Here is where we join the prediction view back into our Customer Explorer. This makes the prediction for every new customer available for self-service. This is very powerful as this enriches the existing data set and democratizes data science to everyday Looker users throughout the organization. I hope from watching this video, a few points become very clear. 1. BQML is simply an extension of your existing LookML semantic layer, which makes building machine learning models fast and agile. The effort to prepare new dimensions and measures for the BQML model contribute back to the semantic layer to make other analyses faster. Second, you don't need a degree in data science to use data science models. The BQML models are simple to use and are called as SQL functions. Third, BQML is super fast and agile because you no longer need to move your data to run the model. You can run these models on your data directly in BigQuery, leveraging all the horsepower of Google. Lastly, all of your users can now benefit from having access to predictions to query and receive alerts. I hope you found this video helpful. Thanks again, and see you next time.